This video is a small tribute from the Geo RGB community to all the people that makes possible the Mars exploration. Currently, we have access to high-resolution images of the surface of Mars, wherein we can see the texture of some of the rocks. In this video, we are going to perform a visual petrological analysis of some of these rocks, and we are going to compare them with the potential terrestrial homologs. We are going to compare the Martian rocks with terrestrial volcanic rocks, bioerosion rocks, and also fossils. At the end of this video, we are going to talk a little bit about stromatolitic structures, because they have been one of the first evidence of biological activity on the Earth record on the rocks. And it makes sense to try to look for a kind of parallelism between the superficial Martian rocks with the terrestrial stromatolitic structures as the first steps of the origin of the life in Mars. Okay, let's go to start.
I'm a hydrogeologist. My motto in life is think out of the box. My name, Marcel. My experience, groundwater and soil contaminations. I'm the creator of Geo RGB, a channel of geographic information systems, GIS, geology, hydrogeology, and contamination. The purpose, the objective, the goal, the intention, the target, the desire. Share my experience and knowledge to create points of discussion. The Geo RGB community. Promote the use of free and open source software. A free digital society. Provide technical advice to environmental companies. An opportunity for professional growth.
Today, we are going to perform a visual analysis of a specific type of rock observed in one of the first images delivered by the Perseverance Rover from the NASA. We are going to use the official NASA link for the Perseverance images. It is about this image. This image can be downloaded in one of the links. It is this link. Here we have two different versions to be downloaded. This one, which weighs 51.8 megabytes, and this one, which is the original and weighs 610 megabytes. I have already downloaded it, and it is this one. This image, as the description says, this is the first 360-degree panorama image from the Perseverance. The image was taken by the Martian set. These are two cameras with a powerful zoom. The panorama was created from 142 individual images taken at the third day of the mission on February 21st, 2021. As this image is a panoramic of 360 degrees, we have to be aware of the potential distortion or deformation of the image. However, for this visual inspection of the rocks, we will consider that the image doesn't present any distortion or deformation. We start from the premise that we don't have any chemical analysis on the composition of the rock, and we don't have any petrological analysis of the rocks to know if they are igneous, metamorphic, or sedimentary rocks. The type of rock that we are going to analyze is the one located near to the Perseverance, the one that presents this type of holes on the surface of the rock. We can recognize this type of rock in several areas close to the Perseverance. As you can see over here, these ones over here, and these ones over here, it's other type of rock. Then we also have then over here, as you can see over here, and these ones are also a different type of rocks. They look something different even though they could be the same. However, the one we are going to be focused is this type, where we can see clearly the porosity on the surface of the rock. When I saw this picture at the first time, I thought that the rocks were from volcanic origin, where these kind of holes were vesicles created due to the released gases, generating this kind of texture on the rocks. However, after zooming, I realized that this type of rocks were presenting a very particular characteristics which I'm going to define right now. As we can observe, the diameters of the holes looks pretty constant and they are very regular on all the rock surface. As you can see in this one, for example, or in this one. Also, we can move to the other side of the picture. In this one, the diameter of the holes is pretty similar. Also, it is observable a dominant direction that it is this one. In this image, we can see it clearly. What we are seeing are small cylindrical channels that presents this orientation, where the diameter of the holes is pretty constant. We can see this type of texture not only in this rock, but also in other rocks around of the Perseverance. We have to understand that the image is a panoramic one of 360 degrees, and the orientation of the rocks in this image is relative. When we take a specific rock, we can see the orientation of these small cylindrical channels are the same. In this case, for example, we can observe that the tubular channels go in this direction. The presence of these tubular channels and the pretty similar diameter of the holes on the surface of the rocks made the texture of these particular rocks very interesting. Terrestrial pyroclastics, that they are fragments of volcanic rocks ejected by the volcanoes, don't present this type of characteristics. However, we have to think that each magma is different and the behavior of the gases inside the magma has also a different behavior. It is true that the gases inside the magma or lava can be released against the gravity and create cylindrical structures that could be similar to these ones. Here we can see that the direction is this one, right? Also, it makes possible to think in other potential scenarios associated with a different type of rocks, instead of thinking just in volcanic rocks. Next, we are going to see a series of images that are pyroclasts to compare them with the rocks that we see on the surface of Mars. To start, we can see this image. They are pyroclasts, and as you can observe in this image, the diameter of the holes are not constant. They are changing constantly, and the vesicles do not show any tabular morphology as we saw on the Martian rocks. Another different rock is this one. Again, in this image, the diameter of the holes are different, and also we cannot see a clear tabular structure. Let's move on the next image. As we can see in this image, the holes are not really deep, and the diameter is not totally round. The shape of the circles are quite irregular. This is another characteristic that we can observe in this kind of rocks. Let's see other image. All these characteristics make the rock very porous and light. In this last image, we have an example where the erosion allows us to see the structure inside of the vesicles. As you can see, there isn't any tabular structure in the vesicles, and they are totally different if we compare what we saw in the Martian rocks. However, all these explanations don't discard the possibility of having Martian volcanic rocks with this type of porosity. We have to be aware that the physical properties of the Mars atmosphere are totally different to the physical properties that we can have in the Earth. Accordingly, the lava behavior and the gases release can be different and create particular scenarios that we cannot be found in the Earth. Then it could be possible to find different textures on the Martian rocks that doesn't exist on the terrestrial ones. Now we are going to analyze a different kind of scenario. In this case, we are going to talk about bioerosion in rocks. I am going to show you an image as example. In this image, regardless of the rock type, it could be an igneous rock, a metamorphic rock, or sedimentary rock, the organisms, as a part of their biological cycles, can erode the rock and create holes, as you can see in this image, and live inside of these holes. Obviously, depending on the rock type, the hardness of the rock, the holes can be deeper, smaller, can have different type of morphologies. Also, depending on the biological activity of the organism, these holes can present different shapes. In this example, we can see holes that are quite round, and more or less all of them have the same diameter. Over here we can see smaller holes. They look different, and this bioerosion could be from a different kind of organism. Next, we are going to see another example, this image, where the diameter of the holes are pretty regular, and it presents tabular holes that look very straight. Another example is this one. And another type of bioerosion associated to a different kind of organism, it is going to be this case. Here we can see a clear clues from the biological activity of the organisms, all these marks on the rock and these holes over here. Let's see another image. In this case we can see how the bioerosion produced by the organisms can be very intensive and erode too much the rock, like in this example where we can see a great erosion. The bioerosion in this case, for example, or even in this one, can have certain similarities with the holes that we observe in the image provided by the Perseverance, where we can see that the holes are vertical as we indicated previously. Maybe this one, it's not the image to see that. Let's move on to a different zone. Here we can see better those type of holes. Where they are showing certain verticality, as we can see here, and it could be something similar to these holes, where all the holes are pretty regular and deep, and they are tabular holes. as we can observe in this zone. If that is true, it will be indicative of the existence of life in Mars, a type of organism that can create this type of structures on the rock. Another example that I want to bring, this one it's a little bit different. It is the existence of organisms that when they fossilize can present this type of holes in the rocks. This is a fossil from a coral. As you can see, it has a series of holes and it can be recorded in the rock. Then here is pretty evident that it is an organism because it is observable a complex structure, and we are not going to see this type of complexity in rocks. However, in other cases, the erosion can erase the biological structures and make them not too really evident. They are not these examples, but it is possible to think in a type of fossil that can leave on the rocks some marks or biological structures of this type. It is evident that here the image resolution is not good enough to identify any type of structure associated with a Martian organism. To finalize, I would like to bring one more example. I saw in several forums that people are talking about stromatolitic structures in this type of rocks, the ones that present a round shape. They are talking that they can be stromatolitic structures. However, the information we have with this image is not enough to say that. Now I am going to show you images of stromatolites. These ones, for example, are current stromatolites in Australia, and they have this type of morphology. Then what we are going to see in the fossil record, for example, if we take a section and we cut from here to here, what we are going to see in the fossil record, it is going to be something similar to this one, where we can see layers overlapping each other. These layers are the result of the biological activity from cyanobacteria. It is known as an algae tapestry. And the cyanobacteria put a layer after layer, and when the layers fossilize, we can get this type of structures in the fossil record. Let's see another example. If we take a different section, in this case a section like this one, what we are going to see in the fossil record, it will be something similar to this one, where we can see how the layers are accumulated one over one and different stromatolites. Another section, but in this case I am going to take something smaller. What we are going to see is something similar to this one, where we can see concentrical circles that represent layers of biological activity of the cyanobacteria. And in this one, it's another section of a current stromatolite. However, the image that we have from Mars, it is not possible to see any type of section where we can see an accumulation of layers one over one. Then the fact that could be stromatolite structures at the moment is discarded, because it is not possible to see any type of structure in layers in the rocks. The hypothesis of the existence of stromatolites is very attractive, because on the Earth they were the first fossil record about the life. Then, if we want to find any type of parallelism, the fact of thinking on stromatolite structures in Mars could be indicative of the first type of life in Mars as we have in the Earth. Unfortunately, with the current information, we cannot make this claim. Well, this is the end of this video. Thank you very much for watching and see you on the next one.